Hi everybody, welcome to another video in Business Calculus, section 10.7, Elasticity of Demand. Before we go there, first we define the relative rate of change and percentage rate of change. So recall that derivative is the rate of change of the function f of x. Then we define the relative rate of change, which is the derivative divided by the function. And so relatively to the function, we find derivative. So we just take derivative divided by the function. And if we use in the chain rule, the relative rate of change is a function that is also derivative of Ln of f of x. So if we use the chain rule, Ln of something is 1 over that thing, and then derivative of it. Doesn't matter what the argument of the Ln is. If it happens to be f of x, then we have 1 over f of x, and then f of x in the parentheses, which gives us the derivative of the function f of x. So we have f prime of x over f of x, and that is relative rate of change, which is derivative of Ln of x. And the percent rate of change is we multiply by 100, and the answer so won't be in percentage. Right. So let's look at the relative rate. Let's find the relative rate of change of this function. So very straightforward. First, we just take derivative of the function. If this is the function, derivative is 50 minus 2 times that, 0.02 x. And the relative rate of change, we take derivative divided by the function. Relative rate of change of the function is the derivative over the function. Derivative is this. Divided by the function, well, original function 50x minus 0.01 x squared. Yeah, very straightforward. And that is the relative rate of change. Next, we will find the percentage rate of change. A model for the real GDP in 1995 to 2002 is given by this, where it is years after 1990. Find the percentage rate of change for f of t for t between 5 and 12. So very straightforward. We just take 100, multiply by derivative, and divide by the function. So this is a function of t, so we take derivative. It's just 300, right? The derivative of t, and then the percentage rate of change is equal to 100 f prime of x over f of x. So 100 f prime, I mean in this case we have the function of t, so I just use t. Right, so we have 100 f prime of t is 300 over original function 300 t plus 600, 6,000, sorry, and then 1,000 times 3,000 is 30,000 over 300 t plus 6,000. So that's what we have. Again, very straightforward. Right now, on to the important part of the section, elasticity of demand. Why is that? And how is that important? What we need to know it. All right, definition. Elasticity of demand describes how a change in price of a product affects the demand. And we define elasticity of demand based on the price level P is equal to the relative rate of change in the demand, which is this, and relative rate of change in price, which is this, where P is the price. Now, if you wonder where is the negative come from, well, the reason of the negative is relative rate of change in the demand and relative rate of change of the price. If the price is increasing, so the rate of change, relative rate of change will be positive. If the price is increasing, the demand will be decreasing. If the price is higher, less people will less likely to buy it, right? So if the price increase, the demand decrease, and if the price decrease, the demand increase. So one increase, one decreasing, and increasing derivative is positive, decreasing derivative is negative. So one is increasing, one is decreasing, one is positive, and one is negative. So we throw in an extra negative here to ensure that the elasticity here is going to be a positive number, right? So I think that's important. So let's just write out a little note here. If the price increase, then demand of the product decrease. If the price decrease, then the demand increase. So one positive, one negative. We throw in an extra negative to make sure that elasticity is always positive, right? Now, of course, relative rate of change of the demand and relative rate of change of the price, divide that, we have elasticity of demand is given by this formula. So when we have X, price demand function, so X is the demand, how many items are demanded, and P is the price, so they relate as a function. So X is a function of P. In that case, elasticity of demand is defined to be this function, negative price times derivative of the function of the price demand equation divided by the function of price. Right. We will have some example later, but now just go to the interpretation of the elasticity of demand. So when we talk about the elasticity for something like rubber, right? But eraser here, if we just make some small change in price, what will the demand be? So we define inelastic, like a hard object, it doesn't matter, you hit it, it's not going to change the shape, right? But for something like the eraser, if we apply the force, it will change the shape. So this one is elastic, this is not. So just like what we have here, inelastic is the demand is not sensitive to the change in price, meaning if we increase the price, the demand will stay the same. If we decrease the price, the demand more or less stay the same. So that is called inelastic. And that is where the elasticity between 0 and 1. Elastic is where the demand is very sensitive to the change in price. So if we just increase the price by a little, the demand will decrease by a lot. If we decrease the price by a little, the demand will increase a lot. As mentioned before, the price and the demand, one increase, one decrease. So elastic is if we apply a small change in the price, will result in a large change in the demand. So inelastic, small change in price result in small change in demand. elastic small change in price result in large change in demand. And unit elasticity, meaning that a change in price produces the same change in demand. For example, if the price increased by 10%, the demand decreased by 10%. In that case, this is called unit elasticity. Of course, unit elasticity is where it is equal to 1. Right, so with that, the interpretation of now, once again, inelastic is doesn't matter. Small change in price does not change much in the demand. So we could think that as a necessity, right? So for the inelastic, that is where the elasticity of demand is between 0 and 1. So just write that out. That is inelastic, and that is defined to be usually necessity, and there's no close substitution. For example, milk, sugar, gasoline, for example. If we want to we have to go to work, for example, the gasoline price increased by 10%, we still have to pay for it. The demand more or less stay the same. Especially gasoline, if the price decreased by 10%, we're not going to buy more because there's no place to put it. I mean, milk or sugar, yeah, we might probably buy a little more, but the change in price will not increase. The change in price will not make a lot of change in those necessity, those items that are necessary. Right, elastic is where the elasticity of demand is bigger than 1. So this is where we have considered to be a luxury rather than a necessity. So luxury item, for example, jewelry first, a few years, 10 years ago or even now, the high-tech product used to be, the high-tech products should be elastic because, for example, if you think on the items that will go on sale on Black Friday, for example, most of them are elastic because the change in price will result in the change in demand. So the small change in price, let's say the price dropped by 10%, the demand will increase by a lot. So more people will be willing to buy that. So bottom line is, if an item, a luxury item, it tend to be elastic. If an item tend to be necessity, it tend to be inelastic. And we apply to that definition to this example. Now, in theory, if demand is elastic, then consumer will more likely to cut purchases if the price increases. So that's why you don't usually see the price increase in the luxury item, because in that case, if the demand decrease, the total revenue will decrease. So that means price increase will result in revenue decrease, and price decreases will result in revenue increase. So for elastic items that are elastic, price decreases will result in revenue increase. So that's why we see usually those jewelry first usually going on sale just to increase the demand, therefore increase the revenue. If the demand is inelastic, the consumer will tend to continue to buy even if there's a small price increase. For example, gasoline, if it increased by a few cents, we still have to buy it the same amount. So in that case, the price increase will result in revenue increase, and the price decrease will result in revenue decrease. So if we have the inelastic, the item that are inelastic, the price increase will result in revenue increase. So that's but that's why there's some regulation against the increase. They cannot just raise the price of gasoline or some necessary item for no reason. Because if the price increase, certainly the revenue will increase. But a lot of people need, because those items are necessary, so their government regulation against increasing the price of those for no reason. Right, now let's look at this first example. For the price demand equation, determine whether the demand is elastic, inelastic, or unit at this price level. So we have this function, the elasticity of demand. Once again, we define to be that. Remember, that's in the negative P, F prime of P, F of P. Right, so just do that. We have the function, now we take derivative. I just copy the function. Right, now I take derivative. It's just negative 2p. Right, so the elasticity of demand negative p f prime of p over f of p we have p f prime is negative 2p over f of p so negative and negative, and then 2p times p, so that's just 2p squared over 1875 minus p squared. Right, now we have different price level, 15, 25, and 40. We just substitute into the equation. Right, so first add p equal to 15. So we say elasticity of demand at when the price is equal to 15. I'm just going to put 15 in for p squared. 15 for p, sorry. 1875 minus p squared, 15 squared. Right, so I just said, instead of x, instead of p, I'm just going to use x. So I store 15 into x, right? And I just type this. Instead of p, I use x. So 2x squared, just put it in parentheses, 2x squared on the top divided by 1875 minus x squared so that's about 0.27. Right, now if this is less than 1, it is inelastic. Of course, when we do this, this should be positive always. So less than 1 elastic, greater than 1, less than 1 inelastic, greater than 1 elastic, equal to 1 unit. Furthermore, let's elaborate a few more. What this number means: if the price increased by 1%, the demand increased by 0.27%. I would say it. If price increases just by 1%, demand, of course, one increase, the other one decreases by 0.27%. Yeah, so that's what this number means. So in that case, if we just increase the price, the demand decrease by a little. So in that case, the revenue will increase. Right. So that's the first one, the price level 15. Now it's the price level of 25. So put 25 in for P. I just simply store 25 into X. And then I just go up there, highlight, copy and paste, or we enter the same function again. To X squared divide 1875. Of course, X squared we can just say X times X, which is the same as X squared. Alright, we have 1. And if it is equal to 1, that is the unit elasticity. Right, in this case, of course, I should say if it is increased by 1% or if it is decreased by 1%, then the demand will increase. Yeah, so one increase, the other one decrease. Should be like that. In this case, if price increases or decreases, I should say slash decreases by 1%, then the demand, if it is increased, it will decrease. Price increase, demand decrease, and increase. Price decrease will result in demand increase by 1%. And then next, of course, when P equal to 40, because now we take 40 store into X, and I just go highlight it, hit enter, copy and paste, and we have 11.64. and if it is more than 1, it is elastic. I run out of space here, but it says if the price increase by 1%, the demand will decreases by 11.64%. So just a very small change in price, the change in demand will change by a lot. Right. Now, let's go back to the theorem we have earlier and think about this for a moment. If it is elastic, the price should decrease if we want the revenue to increase. If it is inelastic, the price should increase if we want the revenue to increase. So inelastic, increase the price, elastic, decrease the price. So if we do that, if we want to get the bigger revenue, once again, if we want bigger revenue, elastic, decrease the price, inelastic increase the price. So if it is unit elasticity, so that will be the perfect place to be. So we don't need to increase or decrease the price, because that will generate the most revenue. So that's the reason about this. Because if it is elastic, we want the price decrease. If it is inelastic, we want the price to increase. Your unit is the perfect balance. Right. So I said I'm run out of space here, but we can say if the price increase by 1%, the demand will decrease by 11.64%. And if the price decreases by 1%, the demand will increase by 11.64%. So that's what that number means. Right. Next, the price demand for equation for hamburgers at a fast food restaurant is that currently the price is at $3. If the price increase by 10%, will the revenue increase or decrease? So how do we do that? How do we know that? Simple. Right. So if we have x plus 400p equal to 3000, so if we solve for x, will be 3000 minus 400p and we define this to be the function of p. So we can find the elasticity of demand. So negative p. By the way, if this is the function derivative is negative 400. 3000 minus 400p. So multiply that 400p over 3000 minus 400p. Right. Now, so currently the price of hamburgers is $3. So what happened at $3? I'll just substitute 3 in there. Elasticity at $3. 400 times 3 over 3000 minus 400 times 3. So that's 1200. At 3000 minus 1200, that's 1800. And that gives us what? 12 over 18, so 2/3. Yeah. So if it's less than 1, so this is inelastic. So if it is inelastic, and they said if the increase by 10%, will the revenue increase or decrease? Right. Think about that again. If it is inelastic, very small change in price have no effect on the change in the demand. So that means if we increase the price by a little, people still want to buy it. So in that case, if it is increased by 10%, the revenue will increase at this level because it is inelastic. Right. Now, how do we confirm that? Well, so X is the number of demand and P is the price. So we can say at P equal to $3, X equal to 3000 minus 400 times 3, and that is 1800, meaning that at $3 the demand for it is 1800. the X is quantity demanded. So the revenue will be 1,800 hamburgers at $3 each. So that's $5,400. Now we increase the price to 10%. So $3 plus 10% of $3 is 30 cents, right? $3.3. That increased by 10%. Right? So just say 3 plus 10% of 3. So the quantity demand 3,000 minus 400 times 3.3. $1,680. So if it is $3, that 1,800 hamburgers are demanded. If the price 3.3, 1,680 hamburgers demanded. So if we multiply the quantity demanded by the price 3 times 1,800, the revenue would be this. Now if we have 3.3 and we times 1,680, of course the revenue increased by $144. Right? Yeah, because it is inelastic, so the price increase, the revenue will increase. Yeah. Inelastic price increase result in revenue increase. Yeah. And we calculate the revenue increase from 5,400 to 5,544. Right, and with that, we finish section 10.7 here. As always, thank you for watching and see you in another video in Business Calculus.